All right, so chapter 2 has been all about the atom. Right? We talked about protons, neutrons, electrons. We talked about how we define an atom, which is by the number of protons, also called the atomic number. We talked about ions. Remember, if we have a difference in the number of protons and electrons, then we have an ion, either a positive ion called a cation if we got more protons than electrons, or we have an anion, which is a negatively charged ion if we have more electrons than protons. Then we talked a little bit about isotopes last time. We said an isotope is something that has the same number of protons, but has a different number of neutrons. And so on the screen, you're looking at a neon sign, like a beer sign or bar sign or whatever. And that neon is made up of 3 different isotopes. We've got what we call neon 21, neon 22, and neon 20. And we can see that it's majority neon 20. It's 90.48% neon 20. There's a little bit of neon 22 there at about 9.25%. And then there's very, very, very small amount of neon 21. And this is true for basically any atom, all right? Any element that we can think of, we're going to have variable isotopes of that particular element, okay, of that particular atom. Some things may only have 1. Some things may only have 2. Some elements may have 15 different isotopes, okay? And so we talked about the concept of a mass number before. We said that the mass number is the number of protons plus neutrons in an atom. And so that's what the number is that you're seeing there. Neon 21, that's its mass number. If you guys look at your periodic table that you've all printed out, because I told you to print one out, right? How many protons does neon have? Neon has 10 protons. So how many neutrons would neon 21 have? So neon's far right hand side of the periodic table. It's number 10, right, on the periodic table, which means it has 10 protons. So how many neutrons would neon 21 have? 11, yeah. 21 minus 10 is 11. Neon 22 has 12. Neon 20 has 10. Changing the number of neutrons changes the isotope. It does not change the element itself, right? Remember, this is how we look at it. We got the chemical symbol. This is one of the ways we can write it. And we can write them a couple different ways, right? We could write it the way that I've got it on the board over there. We can write it with the symbol dash the mass number. We could write it with the name dash the mass number. So you tell me real quick, this is chromium 52. That's hard to see, but it's chromium 52. How many protons and neutrons are in chromium 52? This is not a clicker question. So.
28.
28 what? 28 neutrons. How many protons? 24, that's right. At least I think that's right. I'm assuming that 52 minus 24 is 28. Fantastic. Okay, so I told you that we would figure out how we got those the atomic mass, so those decimal numbers that are on the periodic table. And we briefly talked about before that that was a weighted average of all the isotopes that you could have from that element. And so now I want to show you how they're actually calculated. We're going to ask you to make a couple of these calculations just to make sure everybody knows how to do it, okay? So let's take a look at chlorine, for example. Chlorine is easy because it has 2 isotopes, right? We have chlorine 35 and chlorine 37. Each one of those, if we added up all of the protons, neutrons, and electrons in those different isotopes, we would get an atomic mass. That atomic mass is written in AMU, atomic mass units. And it also has a natural abundance. So chlorine 35 is 75.77% abundant. And chlorine 37 is 24.23% abundant. So that means if I go scoop some up out of the ground, if it's gas, you can't do that. But if I captured it, right, 75% of it would be 35. 24% of it would be 37. Does that make sense? That's just how it shakes out. It's like the neon that I showed you. So the way you come up with that number on the periodic table is we do a weighted average of those things. So take a look here. The atomic mass is written as the percent abundance, written as a decimal, multiplied by how much does that particular isotope weigh. So chlorine 35 weighs 34.97. Okay. For every isotope that you have, you're going to have a set of parentheses like that. Right? So this first set of parentheses here, this is for 35. This is Cl 35. This one is for Cl 37. Right. So again, it's the percent abundance and the mass for each isotope, and then you add them up. Right? If you can do that, you can calculate the atomic mass. If you look up on the periodic table and you look at chlorine, this should be the number that you see on the periodic table for chlorine, 35.45. So this is how it works out, right? For every isotope that you have a set of parentheses. In that parentheses, you're going to put the fraction of the isotope, so what's its percentage, but converted to a decimal, right? Multiply by how much does that particular isotope weigh. And then you add them up. All right, so we're going to have you guys calculate this one and see if you can figure out how to do it, okay? So 2 naturally occurring isotopes of gallium. We got gallium-69, gallium-71. We want you to calculate the atomic mass of gallium. Now, take a look at the numbers for just a second, all right? It's 60% gallium-71, and it's roughly 40% gallium-69. So there should be an average in here that's between those two numbers. Do you agree with that? Which one should it be closer to? Which one is there more of? Okay, so there's more gallium-69. So our average should be between 69 and 71 and closer to 69, right? So that's a way to kind of gut check your answer there, okay? So everybody looks like they're getting 69.72-ish. So here you go, just to make sure, convert each one of those percentages to a decimal. And then you've got here your abundance, that's 60% multiplied by its mass, plus the 40% multiplied by its mass. You add those two numbers together, you get 69.72 like everybody got.